Hi friends, my name is Titan Kumar. I'm working as a physical design engineer in Aptamitra Consultancy. Today I'm going to talk about diode. Diode is a semiconductor device having two terminals that allows unidirectional flow of current, and it's formed by the combination of P and N type. And it's also called as a PN junction diode. So now let's have a look how the PN junction is formed. We can see that this is a two-terminal device with the combination of N-type semiconductor and P-type semiconductor. So here, so in N-type, electrons are the majority carriers and holes are the minority carriers, and in P-type, holes are the majority carriers and electrons are the minority carriers. So this is the formation of PN junction. So here we can see that this is the zero bias condition. It means that there is no potential or any power supply is applied to this junction. This is the region we call it as a PN junction or the depletion layer. Here the holes and the electrons are present due to the thermal excitation. The electrons from inside combines with the holes from the p side and accumulate at the junction of the diode. Here we can see these are the holes and the electrons accumulated. So this region acts as a potential barrier. This barrier potential does not allow any further movements of electrons or holes towards n side or the p side. So it's basically we can call it as a zero bias condition where no external potential is applied, but still drift across the junctions for a certain period of time. So now let's see what is the forward bias condition. So here we can see that this is the forward bias junction. Here, P side is connected to the positive side of the battery and N side is connected to the negative side of the battery. So, when the voltage is applied, here we can see that this positive side attracts the electrons, and here in the negative side it attracts the holes. So, it will repel these positive charged holes, and here it repels the negative charged electrons. So if we need to if we need the current to flow, this barrier should be exceeded, but uh, here we should note that this barrier potential is zero point 0.3 volt for germanium and zero point 0.7 volt for silicon. So the applied for potential when exceeds the barrier potential, the whatever the depletion layer is there, it disappears and the current will flow from the through the diode. Here we can see that the this voltage is greater than the barrier voltage, so the depletion region or the PN junction region is disappeared. This is the reverse bias condition. Here we can see that this N side is connected to the positive side of the battery, and P side is connected to the negative side of the battery. Here, here what happens is these electrons attracted towards the positive side of the battery, and here the holes attracted towards the negative side of the battery. So this, here we can see that the depletion region is wide, because it will uh, here the flow of current is very negligible. However, there is a small amount of saturation current flows through the diode. It's also known as reverse saturation current. The majority carriers are present in the P side, gets attracted towards the end negative side of the battery, and here the uh, positive side electrons are attracted towards the positive side of the battery. This causes depletion region increase considerably towards so because of this attraction, the depletion region gets widened. So it's very difficult. It's because of this, it's very difficult for the current to flow. So uh, in result, the this causes a potential barrier of the device to increase. In such condition, no majority current flows. However, there is a small majority current flows through the circuit, that is known as reverse saturation current. It's noteworthy that after a certain reverse bias voltage, a large reverse saturation current will flow that will permanently damage the diode. So that what we can the, when the potential is more than the breakdown voltage, this there will be a huge reverse bias current, as a reverse saturation current will flow. This will damage the diode. Here we can see that this is the characteristic curve of the diode. Here we can see that up to the breakdown voltage the current is very small. Once it reaches the breakdown voltage, this current starts to increase. As the voltage increases, the current will also increase. Here we can see that in the negative side, this is the reverse saturation current. So till the breakdown voltage, the reverse saturation current is there. Once it reaches the reverse bias, reverse breakdown voltage, the current, reverse current will increase, and this current will damage the diode. Thank you.